Okay, so let's kind of quickly brush upon these. So we had aluminum, 1327. We have selenium, 3479. We have copper, 6429. Calcium, 4020. Bromine, 3580. Molybdenum, 4296. Strontium, 3888. And lead, 82207. Okay, did I miss any? We're okay with writing symbols? Okay. Then the next stage then is to take our symbols and then to identify the number of protons, neutrons, and electrons. Okay, so we'll do aluminum together. So protons, neutrons, electrons. It doesn't really matter what order. That's just kind of order that we do it in. And looking at the symbol, how can I identify the number of protons looking at the symbol? What tells me the answer? Yeah, the bottom number is my atomic number, okay, which is the number of protons. All right, so then I'm going to put 13 for that. And how about the number of electrons? I can also put 13, good, because all my atoms are neutral. They have no charge. So if I have a certain number of protons, they have to have the same number of electrons. Okay, so that makes it a little easy. And then like we just mentioned in the review, number of neutrons is I'm going to take my mass number minus my atomic number to get the number of neutrons, because this number is protons plus neutrons. Okay, so 27 minus 13 give me 14 neutrons. All right, did I go too fast on that? We're okay. I got some nods. Okay, so now you do the rest of them. Right next to the symbol, write the P and E's. Protons, neutrons, electrons. I'll give you a few minutes to crank that out. Okay, selenium, how many protons?
34.
How many neutrons? 35 electrons. Awesome. Copper, how many protons? Neutrons. And electrons. All right, calcium, protons, neutrons, and electrons. Awesome. All right, bromine, protons, right, neutrons, 45, and electrons. 45. Am I going too fast? We're okay? All right. Molybdenum, protons, 2 neutrons. For a little mental math, electrons, 42. Strontium, protons, 8 neutrons, 50, and electrons, 38. Lead, protons, 2 neutrons, and electrons. All right, if you had a quiz tomorrow, you get 100% on that. That's where you got to be. Yeah? Easy peasy? What's that? I'm just saying. Keep you on your toes, right? Keep you accountable. Okay. All good? All right, so now let's reverse it. I'm going to give you some information, and then you're going to write the symbol. Okay? So, it comes up here on the screen for you. Write the symbol for an atom with 14 protons, 14 neutrons, and 14 electrons. So now we're going to go the other way with it. Haley knows.
Well, she's looking it up. There you go. Oh, look, it all synced.
You got it. Look at that. Okay, there you go. Have fun. Okay, symbol. What do we got? What's that? 14. 14 protons. Who we have? Silicon. So 14 here. What goes up here? According to this, what goes up here? 28. Good? All right, let's do one more. Let's make sure we understand where all the numbers come from. Okay, here we have 62 neutrons, 51 electrons, and 51 protons. Write the symbol with that info. Okay, what symbol do we have? $51, what is it? SB, okay, antimony. Antimony, okay, what goes down here? Bottom left? 51, what goes on top? 113. Again, this is mass number, so number of protons plus neutrons, so I have 51 protons and 62 neutrons. Okay? Excellent. So what I gave you is an isotope. what's on the periodic table is the average of isotopes, and we'll get to that tomorrow. Okay, able to do all that? Feel confident with that kind of stuff? All right, move on. Okay, so for this unit, as we go through and talk about symbols and so forth, we want to always give the mass number and the atomic number and any charges of the ions when we have ions. After this unit, we're going to go back to just the actual symbols of SB or N or Cl. Okay, but for now, we're still learning this information, so we want to write it as you see it up there. Okay, so today we want to look at ions. And who knows what an ion is? Ian.
A atom that doesn't have a neutral charge.
Okay, all right. So we can say it's a charged atom. All right, there we go. So an ion is simply a charged atom. Okay, so all these atoms that we've been working with are neutral. So you have equal number of protons and neutrons, or protons and electrons. So they are neutral. Okay, so in order to get a charged atom, how can an atom become an ion? One or two things. Ezra?
Gain or lose an electron.
Awesome. Very good. So an atom can either gain electrons or lose electrons. So let's look at nitrogen. So nitrogen has 7 protons and it has 7 electrons, so it's a neutral atom. Okay? Now let's say that our atom had a change. It still has 7 protons. Why does it still have 7 protons? Because that's nitrogen, right? If I change the protons, I would change our element. Okay, so still 7 protons. But now let's say that we have 10 electrons. 10 electrons. So it gained 3 electrons. So our neutral atom gained 3 electrons from a chemical reaction or something about the environment. What happens to my atom now? Comes negatively charged, and if you do the math on this, we get a 3- charge. Okay? Now, we write a charge with the number first and the symbol second. We don't write -3. That tells us something different in chemistry. Okay? To make that point, if the number's first and then the symbol is second. So 3- or 2-, 1-, etc. Okay, now, so we have a negative ion, and we got that because we gained electrons. So if you're neutral, we have the same number of each. So if I gain a negative, I become negative. I kind of think of attitude, right? On some days, I'm kosher, everything's great, and other days, I get a bad attitude. I become a negative person, okay? So electrons are like attitudes. They're negative, okay? Now, these ions have a special name. So they're negative ions, gain electrons, so they have a special name. We're going to call them anions. Anions is simply a negative ion. And I remember that because it's a negative ion. Okay, a negative ion. So I'm going to inundate you with a lot of terms here. Okay, and then we're going to use those terms to kind of make sure you keep up with things. If I use a term that you don't remember or kind of fuzzy with, please give me a shout and say, what's that again? What's that again? Okay, because that dialogue is going to help us out. Okay? So when we write the symbol of an anion, like nitrogen, everything is the same. So mass number, atomic number, but now we're going to put the charge on the top right. Now we're going to put the charge on the top right. Okay. So let's look at sulfur. And let's look at so these are anions, negatively charged. Okay, so same thing that we did before. I want to know how many protons, how many neutrons, how many electrons for each one. How many protons, neutrons, electrons. All right, I'll give you a couple seconds to do that mental math. How many protons for my sulfur anion? 16. How many neutrons? 16. How many electrons? 18. You can look at this one or two different ways. Math way, if you look at from the mathematical side, if I have 16 protons positive, then how many electrons do I need to get 2 minus? Okay, you can look at it that way. Or you can look at it in the sense of, hey, if I'm neutral, whatever the number of electrons I gain, okay, tells me what my charge is. So I'm gaining 2 electrons. I'm neutral, I have the same number here. This tells me how many I'm going to gain. So 2 plus 16 gives me 18. So you can look at it from a conceptual standpoint or from a mathematical standpoint. Okay, whatever makes sense to you. Okay, bromine, we have 35 protons. How many neutrons do we have? 36. And how many electrons? 36. Okay, so again, we have 35 electrons, 35 protons. I'm 1 negative, so that's how many electrons that I gained. So 35 plus 1 gives me 36. Or again, if you want to use the math concept of 35 positives, I have to have 36 negatives to get the 1 negative there.
So if there's nothing in that corner, is it just known that it's neutral?
Yes, very good. So if there's nothing here, then our assumption is that it's a neutral atom. Perfect. Good question. Okay with that? Any more practice? What are you thinking? What do you got? Which part? Okay, so so just to clarify, so if I give you the symbol like phosphorus 15, 31, 3. So if I give you this, right, you're kind of fuzzy on the P and E's.
No, I didn't. Like, before you were showing how to make it negative.
Wait, how many up? Before.
You like showed how to make it negative, like how it has a negative charge. Like, I didn't know how to do Like, I get how to find, like, protons, neutrons, and electrons. But, like,
Okay. Yeah, you're not going to know what charge they are until later. Is that what you're asking?
Yeah.
So why is P 3 minus and why is B?
Yeah.
Okay, yeah, we won't know that until later.
Okay.
Okay, whew, we're not ready for that yet. Gotcha. I like the thinking ahead, though. So we're okay with this then? If I give it, okay, awesome. All right, anybody else?
So if it's a 1, or is it?
Yeah, so you can put either dash or you can put 1 minus. Either one's fine. Okay, bless you. Okay, so here's a little bit of advanced thinking for us. These anions are going to change the name of our substance. So when you have an anion, we have a special name for it. Not just anion, but it has a special name. The name is going to change. Okay, the name is going to change. So for example, when you see the word chlorine, because you're memorizing that for our quizzes and stuff, chlorine, this refers to the neutral atom. Chlorine, that's a neutral atom. Okay, so we have the same number of protons as we do electrons. So the name on the periodic table, okay, the name on the periodic table, right, tells me we have a neutral atom. Now, if our atom gains electrons and becomes an anion, then we're going to change the ending to IDE. Did you already know that? Yeah? Good. Okay, so if the element becomes an anion, then we're going to change the ending to IDE. So chlorine, let's say chlorine gains an electron, becomes an anion. What name are we going to give that anion? Chloride. You've heard that term a lot, right? You've heard sodium chloride, right? Your table salt. So you've heard those terms before. Okay, so your anion element is going to change the ending to IDE. It's important because when I'm talking to you and using these terms, and if I say sulfide, you should think of an anion. If I say sulfur, you should think of a neutral atom. Okay, so those terms mean a lot. So this is where the vocabulary is going to come into play. All right. Okay, now try these 4. See how we do with these. You write them down, or you can just practice with people around you. When nitrogen becomes an anion, what name are we going to give it? Nitride. When bromine becomes an anion, what name are we going to give it? Bromide. Oxygen is going to become oxide. And fluorine is going to become fluoride. Okay, isn't that cool? All right, so we want to make sure that we kind of keep up with this kind of I know it's very new for you with these terms and whatnot, okay? So the name means a lot. All right, some more connections here. A non-metal element are going to tend to gain electrons. Okay, your non-metal elements are going to gain electrons. And eventually we'll understand why they do that and answer Lexi's question of why they have certain charges. So your nonmetals are going to tend to gain electrons. These would become your anions.
For example of the anions, would like hydrogen peroxide be one?
There is anion in that compound. So that's a compound. Okay, these are just ions. So a peroxide ion looks like this. Okay, hydrogen peroxide is a compound that looks like this. Okay. Okay, so question, where are the nonmetals located on the periodic table? So it's kind of like the national treasures idea where we have hidden information on the table, okay? Where are the nonmetals located on the periodic table? Now what I want you to do is on my big table, see this red staircase? I want you to draw that on your periodic table. It might already be there, okay? Use a Sharpie, make it dark, make it noticeable enough on your table, okay? Doesn't have to be red. Just make it already there. It might already be there on some of yours. It may not be on some. Just make sure it's there. That staircase is a good thing to have. It helps us understand a lot of information there. Okay, so the elements to the right of the staircase are considered nonmetals. Okay, the elements to the right of the staircase are considered nonmetals. And those are the ones that tend to gain electrons. Not always, but they tend to gain electrons. Now, hydrogen is over here for a good reason we'll learn later. So this is the exception. Hydrogen is the exception to a lot of rules in chemistry, just to let you know right now. Okay? So this is also a nonmetal. It's in red. So that means what's on the left side of the periodic or left side of the staircase? Metals. So the nonmetals are on the right side, and the metals are on the left side. And if you notice, there are a plethora of metals on the periodic table compared to nonmetals. Okay, we don't have maybe, 15 or so, 17 nonmetals, but all these are metals. So these are metals down at the bottom. All these are considered metallic over here. Okay, so a lot more metals than nonmetals. Yes, sir? Yes, and we'll get to that at the end of our unit. Okay, something else I want to have you organize on the periodic table since we're at it. It's something called metalloids. In your notes, just kind of continuation. So we have a staircase. Right side of the staircase we said are nonmetals. Left side we said are metals. And now we have these substances called metalloids. Metalloids. A metalloid is a substance that has both metallic and non-metallic characteristics. Okay, a metalloid has both metallic and non-metallic characteristics. I'm sorry, what's that?
Would that be like mercury, or it's kind of like a liquid most of the time?
No, mercury is a metal. It just happens to be a liquid at room temperature because of its density and properties. Okay, so they have both metallic and non-metallic characteristics, metalloids. And there are 6 of them that I want you to know. Okay, there are 6 metalloids on the periodic table. So we have this divide between metals and nonmetals, okay? So that divide, that staircase, is going to be where we find the metalloids because the metalloids are stuck in between a metal and a nonmetal. So on the staircase, on the right side, we have boron, silicon, arsenic, and tellurium. Okay, those 4 are considered metalloids. Okay, so boron, silicon, arsenic, tellurium. So on the right side of the staircase, those 4. Acetine, some books say yes, some books say no. We're going to leave it as no because it's radioactive. And so we're just going to kind of dismiss it as if it wasn't part of that. On the left side of the staircase, we have germanium and antimony for the other 2 metalloids. Okay, aluminum is a true metal, so it can't be a metalloid. And polonium is also radioactive. So we have germanium and antimony. So those 6 metalloids. So we have boron, silicon, arsenic, and tellurium. So the ones that are touching the staircase. And underneath of that, underneath the staircase, we have germanium and antimony. Okay, you're welcome. So boron, silicon, arsenic, and tellurium are on the right side of the staircase, so they're going to tend to have more non-metal characteristics. Okay, they have both, but they tend to going to be more non-metal in character. And then germanium and antimony are on the left side of the staircase, so they tend to be metallic in character. Still having both, metal, non-metal, but more often than not, they're going to behave as a metal. These 4, more often than not, are going to behave as a non-metal. They still have both characteristics, but most of the time, they have that non-metal characteristic. All right, so learned some good terms today. Very good. Okay, so the other way that we can become an ion is if we lose electrons. Oh. So if we have a neutral atom of magnesium, it's got 12 protons and 12 electrons, so we have a neutral atom. So let's say that our magnesium atom still has 12 protons, but now it's going to lose 2 electrons. It's going to lose 2 electrons. What charge does our ion become? Positive, and becomes a 2 positive. So now we're losing, before we gained electrons and we became negative. Now we're losing electrons and we're going to become positive. Again, I take it back to attitudes, right? If I have a bad attitude, if I'm negative and I lose the attitude, I become positive, right? So if I lose my attitude, or some of it, my negative, right? If I lose some electrons, I become a positive ion. Okay, so I'm going to ask you on the quizzes here, if you gain electrons, you're going to become negative ion or anion. If you lose electrons, you're going to become positive ion, which we have a name for that too, which we haven't gotten to yet. Okay? All right, so then this would become Mg, 2412, and 2 plus for my ion. Some of you have cats at home, right? Some of you have cats? All right, there you go. There you go. What are these things that they walk on? Paws. Okay, paws. So cats have paws, right? Cats have paws. So what we're going to do is, since this is a positive ion, we're going to call it a cation, because it's positive. Kind of cheesy, but it might stick with you a little longer, okay? All right, so a positive ion is a cation, because cats have paws, right? Positive ion. Some people look at the T as a positive symbol. That helps them remember that it's positive. Okay, so A, negative ion, or cation for being positive. Okay. The cations don't change their name. Anions do, cations don't. So I would simply say magnesium ion, magnesium atom. See the difference? Magnesium atom, magnesium ion. I don't say magnesiumide. Sounds kind of weird. So we don't change the ending or the name of the cations. All right, so real quick here, for magnesium ion, how many protons does it have? 12. How many neutrons? 12. How many electrons? 10. Okay, are you able to do that? Is that okay? Did you need another example?
I have a question. It's probably further in, but where do you get the name like oxide,
Those,
chloride?
yeah, those are going to be our polyatomic ions. So that's a good question. So these are called monatomic ions. Monatomic ions. Mono meaning what? One. Atom meaning, atomic meaning atom. So this is a monatomic ion. Okay, down the road, we're going to talk about things like this, PO4 3 minus. This is a polyatomic ion. Okay, that's going to be down the road quite a ways yet, though. Okay, so a polyatomic ion because I have more than one atom that's connected together that has a charge. But we're going to stick with the monatomic ions for a while since we're just getting started. Okay, so here's what we're going to do. I'm going to give you this pun sheet. This is going to be due on Wednesday, so I'll give you some time to camp out with this for a while. Some of you nerdy science people will kind of like this. That'd be me. Okay, so let me explain how this works. So number one is done for you. And it says, what do you do in a play? And you act in a play. So the element is going to be actinium. Okay. Number 5 is an easy one. Look at number 5. Superman's weakness. Anybody want to guess this one? Krypton. Okay, so your job is to look at the periodic table, names and whatnot, and figure out what names might fit some of these puns. You don't need to get them all correct. You have like a range, right, to get full credit. What I don't want you to do is I don't want you to go on the internet and just to get the answers. Okay, this is a fun worksheet for you to become more engrossed in the periodic table, looking at names and symbols and stuff, be more familiar with that. Okay, that's the purpose of this, besides also having fun. So don't go on the internet just to find answers, okay? I don't want just answers. I want you to be engaged with the periodic table. Okay, if you get stumped, you can always email me or ask. I'll give you some hints. Okay, so that's due Wednesday. Give some time to work on that. This is due tomorrow. And this is what we've been working on. And this is just to reinforce, can you do the protons, neutrons, electrons, and symbol writing like we've talked about? And for you guys, let's do the odds. Okay, let's do the odds for you guys. Yeah, for the worksheet. Okay, it says 3.3, this worksheet here. Okay, now only the first page back and front. You don't need to do this one yet. Okay, so it's 1 through 25 on that first worksheet. Okay, just the odds. So you only have like 12 or 11 or something like that. Okay? All right, got 2 minutes here. I think we're caught up with the other class. Yay, that's awesome. And anytime you have questions or concerns, you can email me, talk with me.